Hello there, and welcome. Tonight we drift beyond the edges of certainty, into the quiet spaces where questions are greater than answers. Tonight we let the stars be not only lights in the sky, but doorways to wonder. How many voices echo in the dark? It is a question that seems simple, and yet, when held for a moment, it opens like a cavern, deep and without end. We sit on a small world that glows faintly in the cold of space, and from this perch we ask, are we alone? Or are there countless others scattered across the galaxy, each carrying their own fragile flame of awareness? For as long as human beings have looked upward, we have wondered about the lights that pierce the night. The stars were once lanterns of gods, then fires on distant spheres, then suns of their own, each with gravity and substance, each with the potential to cradle planets. Over centuries, the sky shifted from myth to map, from mystery to measurement. And still, despite all that knowledge, the question persists like an ember that refuses to die. If life has arisen here, can it not have arisen elsewhere? The 20th century brought this question into sharper focus. Telescopes no longer merely traced constellations, they measured wavelengths invisible to the eye. Radio dishes blossomed in fields and deserts, catching whispers from the cosmos. Humanity had, for the first time, ears capable of hearing beyond its own planet. And in that moment of possibility, one scientist asked, how do we shape our ignorance into a question science can carry? In the early 1960s, Frank Drake gathered colleagues in the rolling hills of West Virginia at a place called Green Bank. The Cold War loomed. The space race had only just begun. Satellites were new, astronauts untested, and the universe still seemed vast and unreachable. Yet amid the tension of nations stood a quieter hope. That perhaps, across the stars, we might find not enemies, but companions. Drake did not bring an answer. He brought an equation. But this was no equation like Newton's F-mar, which falls with the certainty of apples, or Einstein's E. McNew, which reshapes energy and matter. The Drake equation was different. It was not a law of nature, but a framework of wonder. Each term was a guess, a range, a possibility. Multiply them together, and you did not find truth, but invitation. Pause with that thought. Imagine a chalkboard, not filled with certainties, but with questions arranged in sequence. How many stars form? How many carry planets? How many of those worlds can cradle life? How many sparks ignite? How many minds awaken? How many choose to speak? How long do they endure? Each question narrows the path, and yet together they illuminate a corridor of possibility stretching across the galaxy. The power of the equation was not in its numbers, but in its perspective. For it asked us to imagine every star as a stage, every planet as a possibility, every silence as an unanswered invitation. It turned ignorance into a map. It gave scientists, dreamers, and listeners a language to speak about the unknown. And yet, in that possibility lies wonder. Because the equation, though fragile, asks us to stretch our imagination across the galaxy. It asks us to consider every star, every planet, every chance for chemistry to stir into biology, every struggle for biology to climb into intelligence, every fragile window in which intelligence may shine before it flickers out. It does not tell us how many voices are out there. It tells us how to ask. Picture this, not as numbers on paper, but as lanterns in the dark. Each term is a spark, faint but real, and when they multiply, they cast a glow across the unknown. Perhaps it will prove dim. Perhaps it will reveal only silence. Or perhaps, just beyond our hearing, it will illuminate companions waiting in the deep. The Drake equation begins with stars. It moves to planets, then to habitability, to life, to intelligence, to communication, to longevity. At each step, the numbers narrow, and at each step, we are confronted with both humility and hope. If even one of those terms leans toward abundance, the galaxy may be thick with voices. If several lean toward rarity, then perhaps we are rare indeed, an accident of accidents, a fragile spark alone in the dark. Pause again. Let the image of Earth settle in your mind. Seen from space, it glows like a delicate lantern. Its oceans blue, its continents brown and green, its clouds drifting like pale veils. From the surface, it feels inevitable. The air you breathe, the gravity that holds you, the sun that warms your skin. But none of it is inevitable. It is the result of chance, filtered through deep time, sculpted by catastrophe and survival. Hold that image. A fragile marble in a sea of black. It could have been otherwise. Venus lost its oceans, its skies thick with carbon dioxide. Mars grew cold and dry, its rivers fading to dust. Only Earth held the balance, and here, life rose not only to survive, but to wonder. That wonder is what we carry tonight. The question, are we alone, is not only scientific, it is personal, it is existential. To ask it is to ask. What does it mean to be here? What is the value of our own awareness, our own fragile flame? If we are surrounded by millions of voices, then we are humbled by company. If we are alone, then we are humbled by solitude. Either way, we are humbled, and humility is a rare gift. Pause once more. Imagine yourself drifting outward, slowly leaving Earth behind. Below you, the planet shrinks to a marble, then to a dot, then to nothing at all. Around you, stars multiply. At first they are points, then rivers, then oceans of light. Each one may hold planets, each planet may hold seas. Each sea may hold possibilities. How many? The equation waits, offering its scaffolding, inviting us to fill in the unknowns. Now imagine the silence that holds them. A silence not empty but vast, waiting, full of echoes we cannot yet hear. Between every star lies distance, and within distance lies mystery. The Drake equation whispers that the silence may hold multitudes, or it may hold only us. Both possibilities are staggering. Both require courage to face, and here is where our journey begins, not with certainty, but with uncertainty. Not with answers, but with questions that expand like waves upon waves. For what could be more human than to live in mystery and still reach outward with curiosity? As we move forward, let us carry that sense of wonder like a flame cupped against the wind. We will follow the threads of the Drake. Equations, stars, planets, life, intelligence, and the fragile span of civilizations. Each step will be both science and story, fact and metaphor, knowledge and humility. And at the end, we may not have certainty, but we may have perspective. So here is the invitation. Join me as we walk this path, through silence and starlight, through probability and imagination. Together, we will hold the Drake equation not as an answer, but as a lantern, guiding us through the dark. And if this thought resonates with you, if the question itself feels worth carrying, let it ripple outward. Like waves across a still lake, let it reach another curious soul. Like this video, subscribe to the channel, and share it with others who wonder. Because the search for life is not only about science, it is a mirror of ourselves. And to wonder together is its own form of survival. Every story written in the language of the cosmos begins with light. Before there were worlds, before there were oceans or forests or voices, there were stars being born. To speak of the Drake equation is to begin here with the first term, the rate at which stars ignite. For without stars, there can be no planets, and without planets, no chance for life. Picture a cloud of gas and dust drifting in the silent reaches of the galaxy. For millions of years, it floats in stillness until gravity, patient and invisible, begins to pull it inward. The cloud collapses, swirls, compresses, and in its heart pressure builds. Hydrogen atoms collide, and the spark of fusion ignites. A star is born. It glows, not like a candle, but like a furnace vast beyond comprehension, pouring energy into the darkness. Around it, matter gathers into disks, and from those disks planets emerge. Astronomers call these regions stellar nurseries. In photographs taken by telescopes like Hubble and James Webb, they appear as colourful veils, crimson clouds, blue wisps, golden filaments. But behind the beauty lies something even more profound: the raw beginnings of creation. In each flicker of starlight lies the potential for warmth, for chemistry, for biology, for thought. The rate at which such stars form has changed across cosmic history. In the early universe, stars were born in torrents, galaxies glowed with furious creation, stars igniting faster than we can imagine. Over billions of years, the pace slowed. Today, in our own Milky Way, astronomers estimate that between 1 and 3 new stars appear every year. It is a modest trickle compared to the past, but a trickle still means abundance, for even one new star carries the possibility of countless worlds. Pause with that thought. Each year, new suns ignite. Some will shine for billions of years, steady and calm. Some will blaze briefly, then collapse into silence. The Drake equation begins here, with this pulse of birth. For every star that forms, there is a chance, a small chance, but a chance, that life may one day look up from one of its planets and wonder. Our own sun was once one of these newborns. About 6 billion years ago, in a cloud at the edge of a spiral arm of the Milky Way, gravity pulled matter together. The sun lit, its light spilled outward, and a disk of dust and ice circled around it. Out of that disk, planets condensed. Jupiter, massive and gaseous, Mars, small and dry, Venus smothered in carbon dioxide, and Earth fragile, imperfect, but fertile enough to cradle life. One star, one chance, and from it came oceans, forests, civilizations, and the very question we ask tonight. The Drake equation begins with the symbol RRRRR, the average rate of star formation in our galaxy. It is a simple number, expressed in stars per year. Yet behind it is a story of billions of years, of clouds collapsing, of gravity weaving patterns, of light spilling into darkness. RRRRRR is not just a rate, it is the rhythm of the galaxy breathing, the pulse of creation still ongoing. But the equation reminds us of something humbling. Not every star that forms is suitable for life. Some are giants, burning too hot too quickly, living fast and dying young. Their violence sterilizes nearby space, their lifetimes too short for life to take root. Others are too small, dim red dwarfs that flicker with flares, their habitable zones narrow, their light both patient and dangerous. Between these extremes lie the stars like our sun, or better still, the quieter orange dwarfs, burning longer and more gently. The equation asks us to count stars, but it also asks us to weigh their temperaments. Not every lantern in the dark is steady enough to guide life. Still, the numbers overwhelm. Our galaxy alone contains between 100 and 400 billion stars. Multiply even a small rate of formation across the vast age of the cosmos, and the result is staggering. Trillions upon trillions of suns have been born since the beginning, and each one carries the possibility of planets, and each planet the possibility of chemistry, and each chemistry the possibility of life. Pause again and let that scale settle. Imagine walking at night through a desert, the sky above you spilling with stars. Each one could host worlds. Each one could cradle oceans. Each one could be the home of creatures asking the same questions we ask. The first term of the Drake equation invites us into this perspective. We are not surrounded by scarcity, but by abundance. Not certainty of life, but certainty of possibility. In this way, the Drake equation begins not in silence, but in chorus. Even if most stars do not host life, the sheer number born over billions of years ensures that the stage is vast. The canvas is wide, the possibilities are many. Life does not require perfection, it requires opportunity. And the stars, patient and numerous, provide it. Our sun is one star among billions. To us, it feels singular, inevitable, the anchor of our existence. But in the galactic library, it is only one volume among countless others. The Drake equation asks us to turn the page and see how many others may hold stories of their own. Imagine now drifting further outward beyond the Milky Way. Look at the Andromeda Galaxy, 2 million light-years away, glowing faintly in the night sky. Within it, hundreds of billions of stars burn. Each year, new ones are born. Extend your gaze still further, and you will find that galaxies themselves are uncountable. Each one carries its own rate of star formation, its own possibilities. The numbers swell beyond comprehension. And yet, within this immensity, we still ask, how many? The Drake equation grounds that immensity in something graspable. R is only one number, but it is a place to begin. If we cannot know the answer to the whole equation, we can at least start here. We can measure star formation. We can observe galaxies. We can count, however faintly, the sparks of creation. And that counting, though small, ties us to the vast. To reflect on this is to feel humility. For our sun, steady as it feels, is only one among many. For every human history, there are countless stars with their own silent histories. For every Earth, there may be thousands of other worlds circling other suns. We do not know which harbour life, but we know that the stage has been set on scales beyond imagining. And so the first step of the Drake equation is also the first step of wonder. Stars are born, patiently, steadily, relentlessly. They carry with them the possibility of life, even if only a fraction will ever host it. And to recognize this is to recognize abundance, not certainty, but possibility blooming on cosmic scales. As we move to the next step, planets, we will see how that abundance narrows, how chance becomes more selective. But for now, let this first thought linger. The galaxy continues to breathe new suns into being. The stage continues to widen. The silence continues to hold more lanterns. And if this reflection stirs something in you, let it drift outward as starlight does, long after the source has faded, still traveling, still illuminating. For wonder, like light, is not diminished when shared. It expands, rippling across the dark, inviting others to look upward and ask with us. If stars are the lanterns of the universe, then planets are the stones upon which life might stand. The second term of the Drake equation asks us to look not only at the suns themselves, but at the companions that circle them. For what use is a star, no matter how steady its light, if it has no worlds to catch its warmth? For centuries, we could only imagine such worlds. Ancient philosophers speculated about invisible spheres orbiting distant suns, but for most of human history, those thoughts were no more than dreams. It was not until the last few decades that the dream took shape as fact. With telescopes sensitive enough to measure the faintest dimming of starlight, astronomers began to discover exoplanets, planets beyond our solar system. At first, they were strange giants, hot Jupiters, hugging their stars in blistering orbits. They did not resemble the familiar architecture of our own system. Many doubted whether Earth-like worlds would ever be found. But as the years passed, the list grew. Thousands became catalogued, then tens of thousands suspected. And a pattern emerged, one both humbling and astonishing. Planets are not rare at all. They are common, so common in fact, that we now believe nearly every star has at least one. Some may have entire families, dozens of companions circling in intricate ballets. The second term of the Drake equation, once filled with uncertainty, has moved closer to certainty. Where once we guessed, now we know. The galaxy is littered with worlds. Pause with that realization. Every point of light in the night sky, every star you see, may carry planets around it. Some may be gas giants, some barren rocks, some scorched by proximity, some frozen in the dark. But among the vast variety, there are bound to be a few, perhaps more than a few, where conditions resemble those of Earth. The question is no longer whether planets exist, but how many might offer the fragile balance that life requires. The discovery of exoplanets also humbled us in another way. When astronomers first looked outward, they expected to find systems like our own. Small, rocky worlds close to the star, gas giants further out. That was the model drawn from our single example, the solar system. But the universe surprised us. Many systems look nothing like ours. Giants hug close, rocky planets scatter in eccentric orbits, and the neat order we thought universal turns out to be provincial. We are not the template, we are an exception. This is the quiet lesson of the second term. We assumed that Earth's arrangement was natural, even inevitable. Instead, it may be unusual. The cosmos reminds us again and again. What feels universal from our narrow vantage point is often particular, sometimes rare. To know this is to walk with humility, yet within that humility lies hope, because even in their strangeness, exoplanets are abundant. For every arrangement unlike ours, there may still be niches where life could thrive. Oceans under thick atmospheres, continents beneath orange skies, frozen moons with hidden seas. The Drake equation does not require certainty of habitability, it requires possibility. And the discovery of countless planets tells us possibility is plentiful. Imagine drifting through the galaxy, star to star. Around one, you find a scorched giant, its atmosphere boiling in the heat. Around another, a super-Earth, heavy with gravity, its skies thick and its seas deep. Around another still, a frozen sphere, surface locked in ice, but oceans liquid beneath. The diversity is staggering, each system a different experiment, each planet a different stage upon which life might or might not perform. The second term of the equation is sometimes written as FP, the fraction of stars with planets. For Frank Drake, in the 1960s, this was a matter of guesswork. He proposed perhaps 20 to 50%. Today, with modern instruments, the estimate has shifted. The fraction appears to be close to 1. Nearly every star carries companions. The number is not only large, it is overwhelming. Pause again, and let that number settle. Hundreds of billions of stars in the Milky Way. If nearly all of them host planets, then there are hundreds of billions of planetary systems. Multiply the average number of planets per system, and the result stretches into trillions. Trillions of worlds, each a stage, each a possibility. The galaxy is not empty, it is crowded with landscapes unseen. But this abundance carries paradox. With so many worlds, why does the silence persist? If planets are common, why not voices? The equation reminds us. Abundance at one step does not guarantee abundance at the next. Planets are plentiful, yes. But habitability, life, intelligence, communication, each narrows the field. At this stage, the story is still one of potential, not certainty. Consider again our own system. 8 major planets, dozens of moons, countless asteroids and comets. Out of this richness, only one is known to cradle life. Venus once held oceans but boiled them away. Mars may have once been warm and wet but froze into dust. Europa and Enceladus hold seas beneath ice, but no proof of biology has yet been found. The abundance of worlds does not mean abundance of life. The equation reminds us to be cautious even as we are awed. And yet, awe persists. For in knowing that planets are common, the question sharpens rather than fades. If there are so many, which ones host oceans? Which ones hold skies rich in oxygen? Which ones are barren? Which fertile? Which forever silent? The abundance invites not despair, but wonder, because it tells us that the cosmos has rolled the dice countless times. Somewhere, perhaps, the dice have fallen as they did here. Imagine again looking up at the night sky. Each point of light is not only a star, it is likely a solar system with planets circling invisibly. Some may resemble ours, others may defy imagination. Some may be lifeless deserts, others teeming with seas. To stand beneath the stars is to stand beneath an ocean of possibility. The second term of the Drake equation gives us this ocean. It tells us that the stage is wide, the canvas vast. Life may be rare, but the opportunities for it are not. And to recognize that is to feel both humility and hope. As we move forward, we will ask harder questions. Out of all these planets, how many can truly support life? Out of those, how many will life actually arise upon? Each step narrows the path, each term dims the numbers. But here, in this second step, let us rest in abundance. For abundance is a gift, even if it is not a guarantee. And if this reflection stirs something in you, let it ripple outward like a tide. Share the wonder quietly, not as command, but as companionship. For the thought itself, that planets are everywhere, is enough to carry into the night, like an echo searching for another ear. If stars give us light and planets give us places, then the next question is simple and yet immense. How many of these places could actually welcome life? The Drake equation calls this term N, the average number of planets per system where conditions allow life to emerge. It is a phrase that sounds technical, but behind it lies a vast ocean of wonder. For to ask about habitability is to ask, what makes a world alive? On Earth, life clings to nearly every niche, from boiling vents at the bottom of the sea to frozen deserts where winds scour rock, from acidic lakes to the thin air of mountaintops living things endure. To us, life feels inevitable, as if the planet itself breathes. But the truth is more fragile. Life depends on balances so precise that a shift in air or water or temperature can erase entire ecosystems. To imagine other worlds as habitable is to imagine that these balances might exist elsewhere. Astronomers often begin with a simple criterion, the habitable zone. It is the region around a star where a planet's surface might hold liquid water. Too close, and oceans boil away. Too far, and seas freeze into ice. Between those extremes lies a narrow corridor where water can flow, and water, as far as we know, is essential for life. The habitable zone gives us a first filter. Look at a star, draw the zone, and count the planets inside it. But the simplicity hides complexity. Venus sits in the sun's habitable zone, yet its atmosphere thickened into a suffocating blanket of carbon dioxide. Mars also lies within the zone, but its atmosphere thinned until its rivers vanished. Only Earth struck the fragile balance, with skies stable enough, oceans enduring enough, climates gentle enough to allow life not only to appear, but to persist. The habitable zone is not a promise. It is only a possibility. Pause with that thought. Imagine a corridor drawn in space, narrow and invisible. Within it, planets may orbit. But only some will hold air that protects without suffocating, seas that nourish without drowning, climates that shift without destroying. The equation asks not only whether a world lies in the corridor, but whether it can hold that balance long enough for life to take hold. And then there are the surprises. Beyond the neat diagrams of habitable zones, life may find other refuges. Europa, a moon of Jupiter, holds an ocean beneath its ice, kept liquid by tides that flex its interior. Enceladus, circling Saturn, sprays plumes of water into space, signs of hidden seas below. Titan, wrapped in haze, has lakes of methane and ethane, chemical seas alien to our biology, but rich in possibility. These places remind us that life may not be confined to narrow corridors. It may bloom in shadows, in depths, in chemistries we barely imagine. This expands the term N into something vast. It is not only about distance from a star, it is about geology, atmosphere, chemistry, chance. A planet may orbit in the right place but lack tectonics to recycle carbon. It may hold oceans but lack continents to stabilize climate. It may be rich in elements but poor in energy. To call a world habitable is to weave many threads together, and many can snap. Yet Earth teaches us something hopeful. Life here arose quickly. Geological evidence suggests that within a few 100 million years of the planet cooling, microbes already stirred in oceans. If conditions allow, life may be eager. It may not wait billions of years. It may bloom as soon as the door is open. This hints that habitability, when present, is not barren, it is fertile. Still, humility tempers hope, because we know only one example, one world, one story, one path. We do not know whether Earth is typical or extraordinary. Perhaps life springs easily wherever water and energy mingle. Or perhaps Earth is a rare exception, a fragile miracle in a galaxy of sterile stones. The Drake equation leaves the door open to both possibilities. Imagine again drifting among stars. Around one, a planet circles within its habitable zone, seas glittering, clouds drifting. Around another, a frozen moon hides a dark ocean, tides stirring its depths. Around another still, an atmosphere thick with haze shelters chemistry yet unborn. Each could be called habitable in its own way, each a different stage. The number nay is not a fixed truth. It is a spectrum of maybes, and beyond the science lies the philosophy. To ask what makes a planet habitable is to ask what makes life itself possible. Do we define life by our own example, water, carbon, DNA? Or do we imagine life built of other chemistries, other elements, other forms of persistence? Perhaps methane seas could host organisms. Perhaps silicon could form patterns of complexity. Perhaps we are too narrow in our imagination. The equation humbles us again. It reminds us that our sample size is one, and one is not enough to claim universality. Yet, perhaps that is the gift. For to wonder about habitability is to admit ignorance, and to admit ignorance is to leave space for wonder. Each planet we find is a question mark. Each moon we study is a possibility. And each possibility deepens the mystery. How many of these worlds, circling silently, hold something alive? Pause again and picture Earth not as a given but as a chance. Its seas could have boiled like Venus. Its air could have thinned like Mars. Its continents could have failed to shift, its carbon failed to recycle, its atmosphere failed to protect, and then we would not be here asking. Habitability is not destiny, it is fortune. To be alive on such a planet is not to be chosen, it is to be lucky. The Drake equation invites us to measure that luck. It asks, among all the stars, among all the planets, how many hold the fragile balance? It does not tell us the answer. It tells us how to frame the question. And in that framing, we see both humility and hope. As we move forward, the question will narrow further. How many habitable worlds actually develop life? How many of those climb toward intelligence? How many endure long enough to send signals into the dark? But here, in this step, let us linger with possibility. For possibility is itself a kind of wonder. Imagine again the galaxy. Billions of stars, billions of planets, millions perhaps within corridors of habitability. Oceans glinting under foreign suns, clouds drifting across alien skies, tides pulling on coasts no eye has seen. Each one is a maybe, a seed, a silence that could hold a voice. The equation multiplies these maybes, and though the number remains uncertain, the wonder grows certain. And if this thought stirs you, let it travel softly. Like mist across a valley, like echoes in a cave, let it drift toward others who also wonder. For questions, like starlight, gain meaning when they are shared. If habitability describes the stage, then life itself is the play. The next step of the Drake equation asks us to imagine, among all the worlds that could support it, how many actually see life ignite. It is one thing for a planet to hold oceans, atmospheres, and gentle climates. It is another for chemistry to cross the delicate threshold into biology. This step is perhaps the most mysterious of all, for here we touch the boundary between the inanimate and the animate, between matter and meaning. On Earth, that spark happened early. Geological traces suggest that within a few 100 million years of the ocean's forming, microbes already stirred in the waters. Stromatolites, layered structures built by colonies of microorganisms, appear in rocks more than 3.5 billion years old. Life, it seems, did not wait long. As soon as conditions were stable enough, it took root. That swiftness suggests eagerness, as if the chemistry of our world was leaning forward, waiting for the chance to organize. Pause with that image. The seas still steaming from volcanic heat, the sky thick with gases, lightning flashing across storms. Within this chaos, simple molecules combined, broke apart, combined again. Somewhere, in a tide pool or a vent at the ocean floor, patterns began to repeat. Molecules aligned in ways that allowed them to copy themselves, however clumsily. Each copy was a little different, and some survived longer than others. From that difference, evolution began. From replication came variation, from variation came selection, and from selection came the first faint steps toward life. The Drake equation gives this step a term, sometimes written as fill, the fraction of habitable worlds where life actually arises. But no equation can capture the mystery of those first sparks. For we do not know whether life is inevitable wherever conditions allow, or whether Earth is an extraordinary accident. Perhaps life emerges whenever chemistry has time. Or perhaps the leap from molecules to metabolism is so rare that it happened only once, here. This is the paradox. The speed of life's appearance on Earth suggests that it may be common. But the absence of known life elsewhere in our solar system suggests that it may be rare. Mars once had rivers and seas, yet no fossils have been found. Europa and Enceladus hold oceans, yet no microbes have been seen in their plumes. Perhaps life is everywhere, waiting beneath ice and rock. Or perhaps it is here alone, a singular spark in an indifferent cosmos. Still, the possibilities stretch wide. Scientists imagine many pathways. One is the primordial soup, shallow seas rich in molecules stirred by energy from lightning or ultraviolet light. Another is the alkaline vent, deep beneath the ocean, where minerals create natural compartments and gradients of energy similar to those used by cells today. Some imagine life carried from elsewhere, fragments of microbes riding comets or asteroids, seeding Earth from the stars. Each idea is uncertain, yet each whispers the same possibility. Life may not be unique to us. Pause again. Imagine the chemistry of a young planet. Oceans steaming, rocks crackling with heat. Molecules drift, collide, form chains. Most break apart. But one pattern holds, and in holding it makes another like itself, a tiny echo, a fragile persistence. From such small beginnings, all of life unfolds. Forests, oceans, birds, whales, human minds. Questions like this one. The miracle is not only that life began, it is that it began from so little. The Drake equation does not ask us to explain the process, it only asks us to imagine the fraction. Of the worlds with oceans and air, how many sea molecules tip into self-replication? How many stumble into metabolism, into persistence, into growth? We do not know. Our evidence is one. But even one is enough to show that it can happen. And if it can happen here, it can happen elsewhere. There is also humility in this thought. For if life is inevitable, then the universe may be filled with it. Microbes clinging to countless stones hidden beneath countless seas. If life is rare, then our existence is even more fragile, even more improbable. Either way, the conclusion is the same. Life is precious, whether it is abundant or singular. Imagine drifting outward again, star to star, world to world. Some are barren, seas dry, skies sterile. Some shimmer with oceans but never spark. But then, somewhere, a tide pool bubbles differently. Molecules align, copies form. The improbable happens and the silence gains a whisper. That is the step the Drake equation asks us to imagine, the leap from possibility to presence. On Earth, that leap reshaped the planet. Microbes filled the seas, altered the atmosphere, spread across every niche. They changed the very chemistry of the sky, releasing oxygen that was at first poison, then promise. They laid the foundation for every lineage that would follow. Life did not merely survive, it transformed its home. The equation's fraction, however small, carries consequences profound enough to alter planets themselves. And so the spark of life is both fragile and powerful. Fragile because it depends on chance, on chemistry balanced just so. Powerful because once it begins, it reshapes everything it touches. The Drake equation invites us to hold both truths, the rarity of the spark and the abundance that flows from it. Pause once more. Think of yourself, breathing, listening, alive. Every cell in your body traces its ancestry back to that first replication, billions of years ago. You are not only the child of your parents or of your species, you are the child of that first molecule that dared to copy itself. To imagine other worlds where life sparks is to imagine cousins we have never met, kin across the galaxy, sharing origins different yet the same. The equation does not tell us how many such cousins exist, it tells us how to wonder. For wonder is not diminished by uncertainty. It grows in it. To ask the question is to honor the spark, whether it is common or rare. As we move forward, the question will sharpen. How many of these sparks climb from microbes to minds? How many rise to awareness, to intelligence, to civilizations that leave echoes in the dark? But here, at this step, let us linger with beginnings. For beginnings hold a quiet power. Imagine again the young Earth. Lightning across a storm, waves crashing on rocks, molecules drifting in shallow seas. Somewhere, something shifted, something new appeared. And from that moment, the planet was never silent again. If it happened here, it can happen elsewhere. If it happened once, it can happen again. The equation holds open that door. And if this reflection stirs you, let it echo softly. Like waves against ancient shores, like whispers across deep water, let it drift into another mind. For the spark of life, wherever it appears, is not only a fact of chemistry, it is a flame worth carrying. Life itself is already improbable. But the next step in the Drake equation asks for something rarer still. How many living worlds give rise not only to organisms, but to intelligence? It is one thing for molecules to organize into cells, for cells to form colonies, for colonies to fill seas. It is another for life to look back at the stars and ask questions about its own existence. On Earth, for billions of years, life was simple. Microbes ruled the seas, building, dividing, consuming, persisting. They altered the atmosphere. They shaped the chemistry of oceans and soil, but they did not build civilizations or speak in voices. For most of Earth's history, there was no intelligence, no awareness that could reflect upon itself. The spark had ignited, but the flame had not yet learned to think. Then, slowly, complexity unfolded. Cells joined together, sharing energy and function. Multicellular organisms appeared, fragile at first, then diverse. The Cambrian explosion scattered the oceans with new forms. Creatures with eyes, with shells, with limbs. Evolution began to experiment with nervous systems, with senses, with behavior. Out of these experiments, intelligence would one day emerge, but only after many extinctions, many false starts, many narrow escapes. Pause with that thought. 4 billion years of life, and only in the last few million did minds appear capable of building tools, telling stories, gazing at stars. Intelligence is not inevitable. It is a path that might never have been taken. Dinosaurs ruled for over 150 million years, vast and powerful, yet they left no radios, No telescopes, no questions recorded in stone. The leap to intelligence is not a guarantee. It is a chance, one possibility among many. The Drake equation calls this term phi, the fraction of life-bearing worlds where intelligence arises. But the word intelligence hides complexity. Intelligence is not only the ability to survive, it is the ability to imagine, to symbolize, to communicate. Dolphins are intelligent, crows are intelligent, octopuses solve puzzles. Yet only humans, so far as we know, built civilizations that left signals detectable across space. Intelligence wears many faces, but only some leave echoes beyond their world. And so the fraction narrows again. Of all the worlds with life, how many sea creatures climb toward reflection, memory, language? How many develop culture, technology, awareness that persists? We do not know. On Earth, out of millions of species, only one built radios and rockets. Perhaps that ratio holds across the galaxy. Or perhaps we are unusually alone, an outlier in evolution's long experiment. Still, Earth offers hints. Once multicellular life appeared, intelligence arose in multiple lineages. Mammals developed large brains, birds complex communication, cephalopods striking problem-solving. Intelligence seems to be an advantage, though not always a decisive one. It blooms, but it does not always dominate. The universe may be full of intelligent creatures that never build machines, never leave their oceans, never touch the stars. Intelligence may be common, but technological civilization may be rare. Pause again. Imagine a planet with oceans rich in life. In its depths swim creatures as clever as dolphins, with languages of clicks and whistles, with cultures passed down through generations. But without fire, without metal, without tools, they never build radios. Their intelligence is real, profound, even beautiful, but it never echoes into space. The Drake equation reminds us that not all intelligence leaves traces we can detect. And yet, here we are. Somehow, through the narrow corridor of evolution, one lineage of primates developed large brains, dexterous hands, complex language. We painted caves, built villages, raised cities, launched telescopes. We began to wonder about our own origins, to ask how many others might be out there. Our existence proves that the fraction phi is not zero. It happened at least once. But whether it is common or rare remains hidden in the silence. Consider also the role of catastrophe. Without the asteroid that ended the reign of the dinosaurs, mammals might never have risen. Without ice ages, humans might not have spread across continents. Without scarcity, perhaps our ancestors would not have learned to plan, to cooperate, to imagine. Intelligence may not only require opportunity, it may require hardship. Perhaps evolution needs pressure, disasters, extinctions, narrow paths that force life to innovate. If so, then intelligence may be less a gift of abundance than a child of struggle. This raises a paradox. Worlds too gentle may bloom with life but never push it toward reflection. Worlds too harsh may extinguish life before it can climb toward complexity. Somewhere between chaos and calm lies the corridor where intelligence can emerge. Earth walked that corridor by chance. Other worlds may walk it too, but not all. Pause once more and think of the silence. If intelligence is common, then why have we not heard? Perhaps because most intelligent life does not seek to send signals. Perhaps because the leap from intelligence to technology is another narrowing. Or perhaps because the galaxy is vast, and even if thousands of civilizations exist, the distances between them drown their voices in silence. The Drake equation does not resolve the paradox. It only reminds us to frame it. Imagine again drifting through the galaxy. On one world, forests filled with creatures that sense, feel, and dream but never build machines. On another, oceans rich with intelligent life that never touches fire. On another still, minds as capable as ours, perhaps even greater, but silent, hidden, choosing not to reach outward. Intelligence is not one thing, it is many, and only some of its forms leave ripples we can detect. On Earth, we tell ourselves that intelligence is the pinnacle, the goal of evolution. But evolution has no goals. It only follows paths of survival. Intelligence may be rare, not because it is difficult, but because it is not always useful. A creature does not need to gaze at stars to thrive. It does not need mathematics to flourish. To imagine intelligence as inevitable is to project our own values. The cosmos may not share them, and yet here we are wondering. The Drake equation asks us to imagine the fraction of worlds where others may also wonder. Whether that fraction is high or low, the wonder itself is enough to carry. For to ask the question is to recognize that our intelligence is not only survival, but reflection. We are aware not only of our lives, but of possibility. As we move forward, the equation will narrow further. Of all the intelligent species that arise, how many develop technologies that send detectable signals into the dark? How many choose to speak? How many remain silent? But here, at this step, let us pause with gratitude. For intelligence, whether common or rare, is precious. It is the ability to know that you exist. It is the ability to wonder whether others do too. Imagine again the first creature that looked at the stars with curiosity. Not yet human, not yet technological, but aware that the lights above were more than decoration. That moment, unrecorded, unseen, was the dawn of intelligence. To imagine that moment happening on other worlds is to imagine kinship, echoes across the galaxy. Whether they exist or not, the thought itself deepens our humility. And if this reflection stirs something in you, let it expand gently. Like a whisper carried across generations, like starlight traveling across space, let it reach another who wonders. For intelligence, wherever it blooms, is not only the ability to know, it is the ability to share. Intelligence is one thing, communication is another. The next step of the Drake equation asks us to imagine, of all the intelligent species that might emerge, how many develop technologies capable of sending signals into the dark. This is the term often written as FC, the fraction of civilizations that reveal themselves. It may be the most human of all the terms because behind it lies a deep assumption that others, like us, would want to speak. On Earth, intelligence flowered in many forms: octopuses, dolphins, elephants, crows. Each shows remarkable awareness, memory, even problem-solving. But only one lineage of primates built machines to extend its voice. Only humans filled their skies with radio waves, their orbits with satellites, their night with signals that could, in principle, be noticed from afar. We became communicable not merely because we were intelligent, but because we were restless, curious, eager to reach beyond ourselves. Pause with that thought. Civilization itself is not inevitable. It requires not only intelligence, but cooperation, culture, and continuity. To send signals into space, a species must pass through fire, agriculture, cities, sciences, technologies. It must persist long enough to build telescopes, and it must choose to use them not only for survival, but for wonder. The corridor narrows again. Out of all the minds that might arise, how many will build tools to shout across the void? For most of Earth's history, the planet was filled with intelligence that remained silent to the cosmos. Whales sang, birds called, wolves howled, but their voices did not cross space. Only in the last century did humanity begin to emit signals strong enough to leave a mark beyond the atmosphere. The first faint radio transmissions, television broadcasts, radar pulses, they ripple outward now, a bubble less than 100 light-years across, thin and fragile against the galaxy's vastness. If another intelligence exists nearby, perhaps they have already heard us. Or perhaps the signals are too faint, already lost to the static of stars. The Drake equation asks us to consider the fraction of intelligences that reach this stage. It is not certain. Perhaps most intelligent species remain like dolphins, social, clever, but bound to their oceans, never lighting fires. Perhaps many species build cultures, but never develop technologies that radiate. Or perhaps they do, but choose not to send. The assumption that intelligence leads to communication may be more projection than truth. Pause again and imagine. On one world, forests filled with creatures as clever as primates, yet their intelligence remains woven into their ecosystem, never building towers, never crafting signals. On another, oceans teem with minds, their language is rich, their songs complex yet unheard beyond their waves. On another, still, civilizations rise, but they choose silence, fearing what might answer. Communication is not simply ability, it is decision. And decisions vary. Humanity itself illustrates the fragility of this step. Our earliest broadcasts were not designed to be heard by others. They were accidents, leakage from technologies serving ourselves. Even today, our most powerful signals are directed, focused beams aimed at spacecraft or planetary surfaces, not at the stars. If another intelligence listened, they might miss us entirely. And as technology advances, our emissions may actually decrease. Fiber optics replace radio, signals compress, transmissions encrypt. Our own communicability may fade even as our intelligence grows. This paradox humbles us. The galaxy could be full of civilizations, yet most may be invisible, not because they do not exist, but because they do not speak in ways we can hear. Silence, then, is not absence, it may be choice. The term FC also asks something deeper. What does it mean to be communicable? Is it only radio waves, or is it any detectable signature? Cities glowing on a surface, gases in an atmosphere that betray industry, spacecraft crossing orbits, artifacts drifting between stars. Perhaps communication is broader than we imagine. Perhaps many civilizations speak through their presence, whether or not they send signals. Perhaps we are surrounded by whispers too subtle for our ears. Pause with that possibility. Imagine drifting across the galaxy and looking down upon worlds. Some glow faintly with lights like Earth at night. Some hold skies thick with gases that can only come from industry. Some launch probes that drift between planets, leaving faint trails of metal. Each of these is communication, whether deliberate or not. Each is a sign of presence. To the cosmos, our actions may speak louder than our words. But the equation also reminds us, even if communication is possible, it may not be wise. Civilizations may fear to broadcast, wary of what might answer. The silence we observe may not be emptiness, but caution. Perhaps the galaxy is filled with watchers, each listening, none speaking. The quiet, then, is mutual. This thought carries both unease and wonder. Unease because silence could mean we are surrounded yet alone, unable to bridge the gap. Wonder because silence itself becomes a mystery, a texture of possibility. To live within it is to live in uncertainty, but also in humility. On Earth, we have already asked this question through projects like SET, the search for extraterrestrial intelligence. For decades, radio telescopes have scanned the skies, hoping to catch an artificial whisper. So far, none has been confirmed, only silence punctuated by the static of stars. But the search itself is a kind of communication. It is us saying, we are listening. It is us admitting, we wonder. The Drake equation cannot tell us the fraction. It cannot tell us how many civilizations choose to speak, how many remain silent, how many vanish before their voices travel far. It only tells us to consider the possibility. And in considering, we glimpse again our own fragility. Pause once more. Imagine Earth seen from afar, a pale dot orbiting a modest star. For most of its history, it was silent. Only now, for a brief century, has it spoken faintly. Perhaps we will continue sending signals for thousands of years. Or perhaps this century is the only moment we will ever be heard. In cosmic terms, it is the blink of an eye. To be communicable is not only rare, it may be fleeting. And yet, even fleeting voices matter. A whisper still changes silence. A single lantern still alters darkness. The fraction FC may be small, but it is not zero. And that is enough to keep us searching, enough to keep us wondering, enough to keep us humble. The next step of the equation will ask us about time, how long civilizations last, how long their voices echo before fading. But here, let us linger with the thought of communication itself. For communication is not only about being heard, it is about choosing to share. It is about sending a piece of yourself into the unknown, uncertain whether anyone will answer. Imagine again humanity's earliest signals rippling outward, carrying music, news, stories, fragments of culture. They travel still, even if no one listens. They are echoes of who we were, drifting into silence. To wonder whether others also send is to wonder whether we are alone, not in existence, but in conversation. And if this thought stirs you, let it drift like an unlit lantern passed from hand to hand. For even silence, when shared, becomes companionship. To speak is rare. To wonder together is rarer still. The Drake equation leads us step by step to a final and sobering question. How long does a civilization last? Even if stars are abundant, planets common, life eager, intelligence possible, and communication chosen, the last term reminds us that all of it may still be brief. The voices that rise may fade quickly, swallowed by silence. This is the term L, the average lifetime of a communicable civilization. On Earth, our own number is not yet written. Humanity has been communicable for little more than a century. In the scale of cosmic time, that span is less than a blink. The pyramids were raised 5,000 years ago. The Roman Empire fell less than 2,000 years ago. Even our oldest myths are younger than the stars that burn overhead. Against billions of years, a century of radio signals is a whisper in a storm. Rest with this thought. Imagine all of human history condensed into a single exhale. Agriculture, writing, empires, revolutions, science, industry, all unfolding in a flicker compared to the lifespan of stars. Our civilization feels immense to us, yet to the cosmos it is fragile, as delicate as frost that melts with the morning sun. If other civilizations exist, how long do they endure? Do they burn bright and vanish, consumed by war, collapse, or catastrophe? Do they linger for millennia, adapting, enduring, learning to live with themselves? Or do some achieve stability, lasting for millions of years, shepherding knowledge across epochs as patiently as stars themselves? History humbles us. Civilizations on Earth rise and fall with troubling regularity. The Sumerians built cities that are now dust. The Mayans raised temples swallowed by jungle. Rome paved roads that still cross continents, yet its empire fractured into silence. Knowledge is fragile. Libraries burn, languages vanish, monuments erode. And yet, humanity as a whole persists. Perhaps the measure of a civilization's lifetime is not its monuments, but its continuity. The fragile thread of memory carried across collapse. But shadows gather as well. The 20th century revealed that humanity now holds power not only to build, but to unmake itself. Nuclear arsenals rest like coiled serpents. The climate warms with dangerous speed. Ecosystems fray. Pandemics remind us of fragility. The same tools that allow us to speak across light years allow us also to silence ourselves forever. This may be the great filter. Perhaps many civilizations rise, but few survive their own adolescence. The silence we hear may not be emptiness, but extinction. Pause again. Picture a galaxy where countless civilizations once bloomed, each lighting its lantern for a moment, each extinguished in turn. Their ruins scatter the stars. Dead satellites circling worlds, Machines rusting in frozen orbits, oceans evaporated, skies poisoned, archives sealed beneath dust. The silence around us may not be vacancy, but a graveyard, and yet there is hope. For the same intelligence that brings peril also brings foresight. We can see our dangers. We can choose differently. Civilizations may learn to endure, to balance, to live within their limits. If they succeed, their voices may last for millions of years, long enough for others to hear. The silence we perceive may simply mean we have not listened long enough. Perhaps the voices are rare but not absent. Perhaps they speak across spans too vast for us to notice. Civilizations whose lives stretch across epochs, patient as mountains, steady as rivers of stars. The term L is the most uncertain of all. It can swing the entire equation. If civilizations last only centuries, then even if they are common, the galaxy may be mostly silent, each voice flickering and dying before others arise. But if civilizations last millions of years, then even a small number could fill the galaxy with presence, their echoes overlapping, their lights enduring. Everything depends on this final fraction. Not how many civilizations begin, but how long they remain. On Earth, we cannot know our own L, we can only imagine. Perhaps we will last only a few more centuries before disaster silences us. Perhaps we will endure as long as our sun, billions of years, spreading beyond Earth, carrying voices across stars. The truth lies hidden in the future, uncertain and fragile. But even the question itself carries weight. For to ask how long civilizations last is to ask how long we ourselves may last. Hold this image. Humanity 1,000 years from now. Perhaps our descendants have built cities on Mars, green valleys beneath domes, ships that cross between worlds, archives of memory stretching across time. Or perhaps we have faded, leaving only ruins, fragments of language carved in stone, signals long stopped. Perhaps future archaeologists, whether human or not, will find our traces, fossils of a species that once spoke briefly, then fell silent. But there are other futures too. Imagine civilizations that survive by choosing humility. Societies that avoid collapse, not by conquest, but by balance. Cultures that slow their pace, living not in decades but in millennia, treating knowledge not as fuel but as inheritance. Some may merge with machines, preserving memory and forms beyond flesh. Others may choose simplicity, living in silence, never broadcasting, content within their own world. Longevity may not look like us, but it may exist. The lifetime of a civilization is not only measured in years, but in values. Do we choose to cooperate or to divide? Do we preserve our planet or consume it? Do we build tools for survival or for destruction? The Drake equation cannot answer these. It only frames the stakes. The silence of the stars reflects not only what is out there, but what might happen here. Linger once more with this thought. Imagine drifting outward past stars and worlds, listening for voices. Some faint, civilizations already fading. Some strong, enduring for millions of years, their signals woven into the galaxy like threads of light. And some never arisen at all, worlds forever silent. The tapestry of the cosmos is woven not only of beginnings, but of endings. On Earth, our story is still being written. We're at the very beginning of our communicable age. Whether it lasts centuries or millennia depends on us. The silence of the cosmos is not only a mystery, it is a mirror. In it, we see our own fragility, our own choices, our own possible futures reflected back. And if this reflection stirs you, let it drift like dust across centuries. Share it gently, as a reminder that silence is fragile and voice is even more so. For the lifetime of a civilization is not only a number in an equation. It is a story of survival, of humility, of wonder stretched across time, as fragile and luminous as starlight, still traveling long after its source has gone dark. We have followed the Drake equation step by step. We have counted stars, imagined planets, weighed habitability, traced the spark of life, considered the leap to intelligence, the choice to communicate, and the span of civilizations. Each term narrows the possibilities. Each term humbles us. And yet, when we multiply them, even with cautious estimates, we arrive at a startling conclusion. The galaxy could be full of voices. Pause with that realization. If even a small fraction of stars host planets, and even a small fraction of those planets develop life, and even a smaller fraction of that life becomes intelligent, then across hundreds of billions of stars, the numbers swell. The equation suggests that we should not be alone. And yet, the night is silent. This silence is the paradox, the tension between expectation and experience. It is known as the Fermi paradox. If the galaxy should be alive with civilizations, where are they? Enrico Fermi, a physicist of the 20th century, once asked the question during a casual conversation. Where is everybody? It is a question that cuts deeper than it seems. If the galaxy has billions of years of history, if civilizations can last millions of years, then even one could have spread across the stars. Even one could have left traces, signals, artifacts. But when we look, we see only silence. No signals, no ruins, no visitors, only quiet. This paradox has many possible answers, each both hopeful and unsettling. Perhaps civilizations are rare, so rare that we are among the first. Perhaps life is common, but intelligence is not. Perhaps intelligence is common, but communication rare. Perhaps civilizations rise and fall quickly, their voices brief, their ruins swallowed by time. Each possibility is reflected in the terms of the Drake equation, each a different path through the uncertainties. Pause again. Imagine the galaxy filled with civilizations, each rising, each falling, their signals too far apart in time to overlap. One speaks, but the others have not yet arisen. Another speaks, but the others have already faded. The galaxy is alive, but out of sync. To each, it feels silent. To each, it feels alone. Or imagine that civilizations endure, but choose not to speak. They listen, they wait, but they do not broadcast. The galaxy could be full of watchers, each cautious, each silent. We listen, they listen, and no one speaks. The silence is mutual, chosen, protective. In this view, the paradox is not absence, but caution. There is another possibility, that civilizations do speak, but in ways we cannot hear. Our search has been narrow listening for radio signals, scanning limited frequencies, watching for patterns familiar to us. But perhaps communication takes forms we do not yet imagine. Neutrinos, quantum entanglement, dimensions we do not perceive. If so, the galaxy may be alive with voices, but we lack the ears to hear. The silence is not emptiness, but blindness. And then there is the darker answer. Perhaps civilizations are common, but fragile. Perhaps they almost always destroy themselves, through war, through climate, through technologies turned against their makers. This is the great filter, the idea that somewhere along the path of the Drake equation lies a barrier that few can cross. Maybe we have passed it, maybe it lies ahead. Either way, the silence becomes ominous. Pause once more and let the paradox settle. The Drake equation suggests abundance. Observation shows silence. Between the two lies mystery. The paradox is not only scientific, it is existential. It forces us to ask not only about the galaxy, but about ourselves. Are we rare? Are we fragile? Are we early or already late? Consider again our own signals, rippling outward, a bubble 100 light-years across. Against the scale of the galaxy, it is almost nothing. Perhaps we have not listened long enough. Perhaps a signal is coming, faint but real, and we have only to wait. The silence may yet be broken. The paradox has shaped our imagination. It haunts science fiction, philosophy, astronomy. It asks us to hold two truths at once. The numbers suggest company, but the evidence suggests solitude. To live within that tension is to live with humility, for we do not know whether the galaxy is empty or full, whether we are exceptional or ordinary. Imagine again drifting through the stars. Each sun has planets. Each planet is a possibility. Some may have oceans, some life, some intelligence, some civilizations. Multiply the chances, and you should find many. And yet, as you drift, you hear nothing. No signals, no greetings, no voices. Only the quiet hum of starlight. This is the paradox embodied. But perhaps the paradox is not a wall, but an invitation. It reminds us that our knowledge is incomplete, that our tools are young, that our perspective is narrow. It urges patience. Civilizations may be far, their signals faint, their timescales longer than ours. To expect immediate answers may be arrogance. Silence may not be final. And even if silence is real, even if we are alone, it carries meaning, for it tells us that our voice matters. If no others echo, then ours is rare, fragile, precious. To exist in solitude is not to be meaningless, it is to be unique. The paradox humbles, but it also deepens wonder. Pause again. Imagine the galaxy not as empty, but as a stage waiting. Perhaps we are among the first civilizations, the early voices in a future chorus. Perhaps the silence is temporary, the opening of a song yet to come. In that view, our responsibility grows. To endure is to ensure that the song begins. To last is to give the future a chance to hear. The Drake equation does not resolve the paradox. It cannot. Its terms are uncertain, its numbers guesses. But its gift is perspective. It shows us that the silence is not inevitable, that the galaxy has the ingredients for life, that the possibility remains open. The paradox is not an answer. It is a mirror. It reflects our ignorance, our fragility, our hope. And if this reflection stirs you, let it ripple outward. Share the question itself, as one might share a flame in the dark. For to live within the paradox is not despair. It is wonder stretched thin, waiting to thicken. Silence is not the end. It is the space in which voices may yet arise. How many voices echo in the dark? We began with this question, fragile and vast, and after walking the path of the Drake equation, we return to it once more. The question lingers, unchanged, yet no longer empty. Around it now cluster images of stars and planets, oceans and sparks, voices and silences. We have multiplied uncertainties, traced probabilities, imagined futures. We have not found an answer. And yet, in the absence of an answer, we have found something else. Perspective. The Drake equation was never meant to solve the mystery. It was meant to shape it, to take the vast, unknowable silence of the cosmos and arrange it into a sequence of questions we could carry. How many stars form? How many cradle planets? How many of those can host life? How many of those lives rise into minds? How many minds choose to speak? How many endure long enough to be heard? Each step does not dissolve mystery, but reframes it into something we can hold, something we can wonder about together. Pause with that thought. To wonder together is itself extraordinary. We are not gods. We are not infinite. We are fragile creatures on a small planet, and yet we have built telescopes, equations, stories, and questions that stretch across light years. The Drake equation reminds us that the most human act may not be surviving, but wondering. Wondering in the face of uncertainty, and wondering aloud so that others may share it. Consider again our pale world, Earth. From space, it glows like a fragile lantern, its thin atmosphere hugging it like silk, its oceans gleaming, its forests breathing. For billions of years it was silent. For For billions of years, it knew only microbes, forests, oceans, creatures without questions. Only in the last brief flicker did it produce a species that looked outward and asked. And in that asking, Earth itself found a voice. The silence of the galaxy remains. Perhaps it is empty, perhaps it is full, perhaps civilizations bloom and fade too quickly to overlap. Perhaps they endure but remain hidden, cautious, quiet. Perhaps their voices are carried on channels we cannot hear. We do not know, we may never know. But silence itself is not meaningless. It is the canvas upon which we paint our questions. It is the stage before the song begins. Pause again. Imagine drifting far beyond Earth, beyond the edge of the solar system, past the planets, past the comets, into the dark between stars. Look back. The sun shrinks to a star among stars. The Milky Way arches like a river of light. Within that river are hundreds of billions of suns, trillions of worlds, countless possibilities. Somewhere, perhaps, others look up and wonder too, or perhaps not. Either way, the act of imagining them changes us. For the Drake equation is not only about the galaxy, it is about us. Each term is a mirror. Stars remind us of our own sun. Planets remind us of our own Earth. Habitability reminds us of the fragile balances that cradle us. The spark of life reminds us of our improbable origins. Intelligence reminds us of our rare awareness. Communication reminds us of our choices. Longevity reminds us of our responsibilities. To walk the equation is to walk a circle that returns us home, humbled but illuminated. Now linger here in the silence. What if we are alone? It is a sobering thought. If true, then our responsibility grows immense. We carry not only our own future, but the future of consciousness itself. If no others exist, then the extinction of humanity would mean the extinction of awareness in this corner of the cosmos. That realization should humble us. It should remind us to endure, to preserve, to survive, to keep the flame alive not only for ourselves, but for existence itself. But what if we are not alone? That too humbles us. For then we are one voice among many, one lantern among billions. Our responsibility is still immense. To endure long enough to listen, to endure long enough to answer, to endure long enough to join the chorus. To live not only as survival, but as connection. In either case, alone or not, the conclusion is the same. Our voice matters, our presence matters, our choices matter. The Drake equation does not resolve the mystery, but it sharpens its stakes. Silence is not only a question of the cosmos, it is a reflection of us. Imagine again the future. 1,000 years from now, perhaps we have built cities among the stars, archives orbiting suns, memories etched into diamond and light. Or perhaps we have left only ruins, fossils of machines rusting in dust, signals long stopped. Or perhaps, most likely, something in between. Fragile continuity, with rises and falls, collapses and renewals, voices faltering but never silenced. Civilizations may not be immortal, but their echoes can endure, pass like torches from one age to the next. And imagine even further, 1,000,000 years from now. The continents have shifted, the stars themselves have moved. Civilizations may come and go, but perhaps memory endures, etched into artifacts, carried by machines, whispered in the DNA of creatures that inherit the Earth. Perhaps the cosmos will never hear us, but the echo of our presence will remain, faint but real, like starlight traveling long after its source has gone dark. Rest for a moment with that image. Starlight still moving, though the star is gone. Echoes still rippling, though the voice has faded. Perhaps that is what civilizations are. Temporary flames that leave long shadows. We may vanish, but the fact that we existed cannot be erased. The universe itself carries our mark. And so we return to the question. How many voices echo in the dark? Perhaps many. Perhaps few. Perhaps only one. The Drake equation cannot tell us, but perhaps the number is not what matters. What matters is that we ask. What matters is that we listen. What matters is that in the vast silence we carry our own voice carefully, like a flame cupped against the wind. As our journey ends, let the silence close gently around you, not as emptiness, but as stillness, not as despair, but as company. Silence is not absence, it is possibility. And within it, even one voice is extraordinary. So let this reflection linger. Let it ripple outward like waves across still water. Share it, not as command, but as companionship. For the question itself is worth carrying, and to carry it together is its own form of survival. How many voices echo in the dark? We may never know. But tonight, as you listen, one does. Yours, ours, humanity's. And that is enough to remind us that silence is alive with wonder,